Hi everyone, it's Math with AUB. Let's embark upon our journey as usual for the preparation of SAT, SAT, GRE and GMAT. Question number 1 reads as a good question. As mine. I try my best to select some quality question. No compromise on quality. I try my best to see for you some tremendous questions, not an ordinary ones. In a group of buffaloes, lump sum is our question number 16, if I am not wrong, 16, it's 17, 18, then it's 19. Okay, lump sum. In a group of buffaloes and ducks, the number of legs are 24, more than twice the number of the heads. What is the number of buffaloes in the group? In a group of buffaloes and ducks, the number of legs are 24, more than twice the number of heads. What is the number of buffaloes in the group? We have given, let me show L for legs. L denotes legs. Legs are 24 more than twice of the heads. I have written H for head, L for leg. In a group of buffaloes and ducks, the number of legs are 24, more than twice the number of heads. Just translate this sentence mathematically, that is, number of legs is equal to 24, more than double the heads. Number of legs is equal to double the heads plus 24. That is our first stage that we have arrived at. Let's hoist the flag of understanding here. That's our L is equal to 24 plus 2H. Furthermore, the twist in the tail is here. Let's open it up. For buffalo, 4 legs. For a buffalo, it has 4 legs, while duck has 2. Normally, open number of legs, 4 with B. B stands for buffalo. Buffalo has 4 legs. While duck has 2. Duck has 2 legs. Number of legs is equal to 24, more than double the head. I have explained number of legs. Buffalo has 4, while duck has 2. Buffalo has 4, duck has 2 legs. 24 plus twice. Here comes head. In case of buffalo or duck, they have single head. Both have single head. In case of head, buffalo has 1 head as well as duck. So 1B plus 1D. That is the science. That's the chemistry behind number of legs. Buffalo has 4 while duck has 2. In case of head, buffalo has 1 as well as duck has 1. In case of heads. Now solve for B to get number of buffaloes. 4B plus 2 times D is equal to 24. Multiply 2 throughout, it will become 2 times buffalo, 2 times duck. Solve for B. B here, shift 2D here, we are going to get something like this. Nice, elegant linear equation. 4B minus 2B. 24 is there, 2D is there. Shift this positive 2D towards left, change the symbol to 2D. They are no more. We have 4B minus 2B. 2B is equal to 24. Solving for B. B is 24 over 2. So number of buffaloes in this case is 12. Number of buffaloes is 12 in that case. Now, what is given to us? The data, the number of legs are 24, more than twice the head. Number of legs 24, more than twice of the head. Then further we have spill the beans. Legs. In case of legs, buffalo has 4 while duck has 2. In case of head, both have single head. 1B, 1D. Normal. Then solve for B. So number of buffaloes in that case is 12. Is 12. Moving towards next question, we have. Moving towards next question, find the square root of 7 minus 2 times square root 10. Find the square root of 7 minus 2 times under root 10. Square root of 7 minus 2 times square root of 10 is square root of 10. It's a wonderful question, elegant question, prevailing on FB here and there. Good question. 7. Let me factorize 10 2 times 5. 2 times 5. Still I can write 7 minus 2 times. It is distributed in case of multiplication. 2 times square root 5. Under root 10 can be written as 2 times 5, or they can be, in this case, in case of multiplication, square root is distributed. We can write in that fashion. Okay. Now this is our guiding, principle. 2 and 5. If we add them up, we will get 7. If I split 7 like 5 plus 2 minus 2 times root 2 root 5. Now our question is going to take shape. This is 2 times AB. Here must be A square B square. Further, everything is clear that there is root 2 root 5. If I can write 5 as root 5 square, while I can write 2 as root 2 square minus 2 times root 5 times 2. Now here, just compare the situation. It's A square plus B square minus 2 times AB. That is the situation. There is a perfect square quantity of A minus B squared. A minus B squared. A minus B whole square. A minus B whole square. So, writing its brief form, it is A and its B is symbol. Square root of 2, negative square root of 2 whole square. It is our A square plus B square minus 2 times AB. A square plus B square minus 2 times AB. Here our A is root 5. A is square root 5 and B is root 2. B is root 2. Square and under root are cancelled out. What we have? Square root of 5 minus square root of 2. Normally we take square root as positive as well as negative. This is the square root of 7 minus 2 under root 5. Here is positive, so we can write square root can be factored in positive and negative. Root 5 minus root 2 is square. If you verify this one in retrospective fashion, still it is a welcome step. Open this up. Root 5 minus root 2 is square. Open this up. It's our A square minus twice A into B plus B square. Here it is 5. Here it is square root 2. Here it is root 5. Here it is root 2. Square and root cancel 5. Minus 2. They are multiplication, no symbol in between. We can multiply them 2 from the 10 square root plus 2. 5 and 2. That is our 7 minus 2 square root 10. One can work in retrospective fashion from the factors. Our option number C is the right answer in that case. Such type of question, they are prevalent in FB type, Olympiad type question. Olympiad type question it is. Olympiad type question. Moving towards next question, a generalization type question. 1 minus 1 over 3 times 1 minus 1 over 5 times 1 minus 1 over 5 up to 1 minus 1 over 100 is equal to what? Is equal to what? The larger the question, the longer the question, the simpler the solution, It's my belief in maths. We have 1 minus 1 over 3 times 1 minus 1 over 5, 1 minus 1 over 5, dash continue till 1 over 100, 1 minus 1 over 100, 1 minus 1 over 100. It's a really simple situation. Just take LCM. Let's see what props up it geysers. 3 1 are 3, 3 minus 4 LCM, 4 on the 4 minus 1. Here it is 5 LCM, 5 on the 5 minus 1, and so on. 100 minus 1 over 100. Okay. 3 minus 1, it will become 2 over 3 times 3 over 4 times 4 over 5 times 5 over 6. Let me continue the journey in order to clarify the situation. Up till 97 upon 98, one can write 98 over 99, that is 99 over 100. One can generalize this first. One can generalize this first. Look at this. Cancelled out, cancelled out, cancelled out, cancelled out, cancelled out. Each term cancelled out except the first one and the last one. They are also cancelled out. The first one in the numerator, the last one in the denominator. The first figure is R2, the last figure is R100. The rest has been cancelled out. The rest has been cancelled out. Our answer is going to be 2 times 1 over 100. Applying table. 1 over 50 is the question. 1 over 50 is the question. Still, if you have any objection or lack of understanding, there is something missing, it obfuscates your understanding, it perplexes you, just simplify the situation. If I am taking this one up to 10 and opening this up for you, 1 minus 1 over 3, 1 minus 1 over 5, 1 minus 1 over 5, 1 minus 1 over 6, 1 minus 1 over 7, 1 minus 1 over 8, 1 minus 1 over 9, times 1 minus 1 over 10. We are taking up to 10. Taking LCM, it is R3, 3 minus 1. 4 minus 1 over 4. Here, 5 minus 1 over 5. 6 minus 1 over 6. 7 minus 1 over 7. 8 minus 1 over 8. 9 minus 1 over 9. And here, 10 minus 1 over 10. Simplify the situation. It's 2 over 3, 3 over 5, 4 over 5 times 5 over 6, 6 over 7, 7 over 8, 8 over 9, 9 over 10, 9 over 10. That's our final. Look at this. Cancelled out, cancelled out, cancelled out, cancelled out, cancelled out, cancelled out, cancelled. What remains? First from the numerator, the last from the denominator. We have 2 over 10. 2 over 10 means 1 over 5 is our final answer in that case. I have taken just finite and light figure from 1 to 10, 1 to 10, and we have manipulated the situation. What remains? First and last, first and last. So, the brief form of this will give you good idea to hunt down this question, to understand this question. We have taken from, we have started from 3 to 10, 3 to 10, and it is from 3 to 100, 3 to 100. Each term keeps on cancelling except the first in the numerator and the last one's denominator. They prevail, the rest get cancelled out. These two prevails, the rest cancel out. 2 times 1 over 100 means 1 over 50 is our answer in that case. Here, option number C is the right option. Moving towards next question we have, if x is equal to 3 plus 2 times square root of 2, if x is equal to 3 plus 2 times square root of 2, find the value of root x minus 1 over root x. 1 over root x. A good question, a pleasant question. Definitely it is going to knock you down whenever you attempt this one first time. If you ponder over and work as a cautious mathematician, cautious mathematics learner, you are going to crack this nut. Okay. My first tip to you, check their difference, square them and check their difference. Square of 3 is 9, square of 2 times root 2 is 8. Their difference is 1, their difference is 1, their difference is 1. Then it's very cool to assume that their reciprocal is going to be 3 minus 2 times root. Difference is 1. The square of these two terms, the difference of the square of these two terms is 1. Then it is very safe to write 3 minus 2 under root 2. R1 can rationalize. R1 can rationalize like this. 1 over x. 1 value of x is 3 plus 2 under root 2. Next step rationalize. Next step rationalize. 3 plus 2 times root 2. Divide and multiply. Change the middle symbol. Change the middle symbol and multiply and divide. 3 minus 2 times root 2. 3 minus 2 times root 2. So we have 1 over x. Multiply with one numerator, it makes no difference. 3 minus 2 under root 2. Here, the difference of two square situation previous, merge them, it's equal to a square minus b square. Here a is 3 and b is 2 times root 2. We have 3 minus 2 times root 2. The square of 3 is 9, the square of 2 is 4, the square root 2 is only 2. 4 times 2 is 8, 9 minus 8. So that is 3 minus 2 times root. That we have already managed and are prepared for ourselves. Their difference is one. It's very safe to write that 3 minus 2 under root 2. Change the middle symbol, change the middle symbol, change the middle symbol. And we have done so by definition. This is x, this is 1 upon x. Now twist in the tail. Add them up, x plus 1 over x. If we add them up, they get cancelled out. 3 plus 3, it will become 6. 3 plus 3, it will become 6. Add them up, x plus 1 over x. 2 under root 2, positive, negative, cancelled out. 3 plus 3, 6. 3 plus 3, 6. Now, the real saga, the real drama starts. We are asked to find the difference of root x and its reciprocal. We are asked to find the difference of root x and its reciprocal. Or to get to that, let's see and find out. Take this, root x minus 1 over root x. We have to transform this quantity into x. Because we have the values of x and 1 over x. It is very hard to manage root x minus 1 over root x from x. However, in retrospective fashion, from root x minus 1 over root x, we can manage this. Simply square this bracket. It's tantamount to a square negative twice first into second plus square of second. We have root x here 1 over root x. Root x here 1 over root x. Get cancelled. We have x minus 2 plus 1 over x. X minus 2 plus 1 over x. On the left hand side, we have x minus 1 over root x. 1 over root x whole square. If we collect x terms and replace their value, x plus 1 upon x is equal to 6, we are going to get something. And our question is taking shape. X minus 1 over x whole square. We can write x plus 1 over x minus 2. Instead of x plus 1 over x, we can utilize this value. X plus 1 upon x is equal to 6. That is 6 minus 2. 6 minus 2. 6 minus 2. We are going to get something like what? Let's see. We have root x minus 1 over root x whole square. 6 minus 2, we have 4. Taking the square root both sides, we have root x minus 1 over root x. And there is square root of 4. The square root cancel. We have managed the value of x minus 1 over under root x is equal to 2. So we have root x minus 1 over root x is equal to 2. That's our answer. Very puzzling question, very perplexing question, very demanding question. But however, it is easy one. We have x. Square them and check their difference. Their difference is 1. It's very safe to write 1 over x as 3 minus 2 times root 2. Add them up. We have the value of x plus 1 upon x as 6. It is very hard to go from x to root x. However, take this quantity x minus 1 over root x, square it. Its square will give us x plus 1 over x. And we have already the value of x plus 1 over x that we have prepared, it's equal to 6. That it is equal to 6. We have utilized the value of x plus 1 over x, and here the situation that is the required root x minus 1 over root x is prevalent. We have to just get rid of this square. Taking the square root both sides. We have root x minus 1 over root x is equal to 2. These are our questions from 16 to 19. We have done some 20 classical questions for the preparation of SAT, GRE and GMAT. We have omitted the average or simple questions, just good one, a quality question. The demanding. At first sight, they have the potential to give you a jolt. It's my tiny effort to you guys. It's all by itself. Next.